Welcome to Maths and Science by IITian. On complex numbers, it is the 8th lecture. Until now, we have completed 7 lectures on complex numbers, on various definitions and typical problems. And in this lecture on complex numbers, we deal with complex conjugates. We'll deal with complex conjugates. What is the meaning of a complex conjugate? How do you represent it in the geometrical plane? And what are the multiplication, subtraction and addition of complex conjugates? Addition, subtraction, multiplication, division of complex conjugates with the original complex number. What is Z bar? Z bar is equal to complex conjugate. Once we know what is Z bar, then we have to find out what is Z to the power of n bar. We will be calculating that. Now, we will move further. What is given here? Let us say, let Z is equal to x plus iy, a complex number. Original complex number given. How do you represent it geometrically? Because it's a complex number, we have to draw the complex plane. This is the real number on x-axis. This is imaginary number on y-axis. What is the component of on x-axis? It is x. And on y-axis, it is y. This is point P, x, y, and this is origin. I might have explained you many times this one, but this is very, very important. For that only I am repeating it. And OP bar is equal to Z bar, where Z is equal to complex number x plus iy. OP bar is the vector, magnitude of the vector OP bar. Now, if xy is the point on the complex plane for Z, from the definitions which I have defined in the previous classes, previous lectures, please refer to them, previous 7 lectures. Z bar is equal to, it is called as conjugate of Z. That implies Z bar is equal to x minus iy. In the plane of complex plane, how do you represent x minus iy? This will be x is same x only. X is not changing its sign, but y is changing its sign. The point here is x minus iy. Origin we are not changing. This we will call it as q. X minus y. Z bar is nothing but x plus I into minus y. X minus iy is nothing but x plus I into minus y. This is called as the imaginary part is a negative. In the original number, if it is in z, if it is positive, it gets turned into negative imaginary part. The sign of the imaginary part changes in conjugate. That means if z is equal to x plus iy, then z bar is equal to x minus iy. This is what is the conjugate by definition. And conjugate is represented like this. This is z and this is z bar. Geometrically it is represented in this manner. Now we'll go into the addition of conjugate number with the original number. What is the meaning of z plus z bar? That is equal to x plus iy plus x minus iy is equal to 2x. Because plus iy and minus iy get nullified, then it becomes 2x. Z plus z bar is equal to a real number. It's not a imaginary number. Then what is z minus z bar? That is equal to x plus iy. Please, even though it looks simple, we have to be very careful in making these calculations. What is z minus z bar? Z minus z bar is equal to y I into 2y. That is imaginary number. The difference of a real number, a original complex number and the conjugate complex number of the same complex number, the difference is an imaginary number, the addition is a real number. This is very, very important. Please remember these two. Look simple, but they have a lot of applications in engineering and sciences. Now, what is the meaning of z plus z bar whole bar? The conjugate of z plus z bar. What is the conjugate of z plus z bar? Z plus z bar is 2x. The conjugate of z plus z bar is z plus z bar is equal to how much? That's what we have to find out. Z plus z bar is equal to 2x plus I into 0. Because imaginary number is 0. Which implies z plus z bar whole bar. Conjugate of z plus z bar is 2x minus I into 0. That is equal to 2x. That means z plus z bar whole complex, again conjugate is equal to z plus z bar whole again conjugate is equal to 2x, which is nothing but z plus z bar. Very, very important concept, regularly being used in engineering, mathematics and sciences applications. Z plus z bar If Z is a complex number, original complex number, Z bar is its conjugate, the sum of the Z plus Z bar, the conjugate and the complex number is equal to a real number, that is equal to the conjugate of the whole number, Z plus Z bar. Very important. Please remember this. In objective type questions also, this type of question may come. I will explain about the MCQ at the end of the class. Now, what is Z minus Z bar? We have seen it is an imaginary number that is equal to how much? I into 2y. I is iota. I call it as I because calling iota, instead of calling I as iota every time, I call it as I. I into 2y. Now, this is an imaginary number. What is the value of Z minus Z bar conjugate? The whole conjugate of Z minus Z bar is how much? As we have done in the addition, with the same principle, we will do it in the subtraction. Z minus Z bar is equal to I into 2y is equal to 0 into x plus I into 2y. Then Z minus Z bar whole conjugate is equal to 0 into x minus I into 2y. Z minus Z bar whole bar is equal to the conjugate of Z minus Z bar. The whole conjugate of Z minus Z bar is equal to Z bar minus Z. This is also a very important observation we got from above. Important observation. Now, let us go for multiplication. Z is equal to x plus iy. Z bar conjugate is equal to x minus iy. What is the meaning of Z into Z bar? That is x plus iy into x minus iy. You please try to understand. This is nothing but x square plus I into xy minus I into xy plus y square. That is x square plus y square plus I into 0. That means Z bar is equal to x square plus y square plus 0 into I. Sorry, I into 0 we can even write. It is a real number. Now, we will go for it is a real number. There is no imaginary part in this. Since I square is equal to -1. Now we will go for Z by Z bar. That is division. Z is x plus iy divided by x minus iy. Let us multiply both numerator and denominator by x plus iy. This is x plus iy into x plus iy whole divided by x minus iy into x plus iy. This is equal to x square plus I into 2xy minus y square, because I square is equal to -1. Iy into iy is plus I square y square. I square is -1, hence minus y square is come. Here x plus iy into x minus iy is nothing but x square plus y square. That implies z by z bar. We are here operating only the given complex numbers, conjugate and complex numbers. We are not taking different complex numbers here. Please try to understand. For the same complex number z, we have found the conjugate, and we are going to explore if the complex number is added to that its conjugate, what happens. When the complex number is added to subtracted, the conjugate is subtracted from the complex number, what happens. When the conjugate is multiplied with the same complex number, what happens. When the conjugate is divided, when conjugate divides the original complex number, what happens. These are the things we are concentrating on. We are not taking two different complex numbers. Then what is z? Z by z bar is equal to x square minus y square by x square minus real numbers, we will take it separately, by x square plus y square plus I into 2xy by x square plus y square. That means it is a complex number. A division of a complex number by its conjugate produces a complex number, provided x square plus y square is not equal to 0. That means x and y non-trivial solution. X and y are not equal to 0. X is equal to y is equal to 0. That's a trivial solution. If for a non-trivial solution, it's a complex number. Non-trivial means x is trivial means x is equal to y is equal to 0. Non-trivial is which is non-trivial. X is not equal to 0, y is not equal to 0. That is non-trivial solution. Now, the non-trivial solution of z by z bar is equal to x square minus y square by x square plus y square plus I into 2xy by x square plus y square. Now, I will give one MCQ for your thought process. MCQ on the above. The division of a complex number by its own conjugate results in answers A. Imaginary number, B. Real number, C. Complex number, none of the above. if it is for non-trivial situation. Non-trivial situation. Answer is, we have seen already, it gives a complex number. When you know the background of conjugate and the complex number, then you can understand what is the multiplication, what is the division, what is the, what you call, multiplication produces real number, addition produces real number, subtraction produces imaginary number, whereas division produces a complex number. Please remember these four things. Now we will go to the final one. What is Z bar? What is actually we wanted to find out? Z to the power of n whole bar. Now, if Z is a complex number, and we are talking about non-trivial solutions, here assume Z is equal to x plus iy. That implies Z to the power of n is equal to x plus iy to the power of n. That is equal to x plus iy into x plus iy into x plus iy up to n terms. For a non-trivial condition, and when x is not equal to 0 and y is not equal to 0 for non-trivial conditions, this will be a complex number, a capital X plus capital Y. This will be in this form. This capital X can be, depends upon the n value. The capital X, real parts are separated. You might have seen in the multiplication what happens. It is not conjugate. We are not multiplying with conjugate. We are multiplying a complex number with the same complex number, same complex number, same complex number for multiple times. For example, if n is equal to 1, z to the power of 1 is equal to x plus iy. If n is equal to 2, z to the power of 2, z square is equal to x plus iy into x minus iy, x plus iy. It is not conjugate, same number we are multiplying. X square minus y square plus I into 2xy. And when n is equal to 3, z cube. That is x square minus y square plus I into 2xy. This is multiplied by x plus iy. It results in x cube plus 3a plus b whole cube is equal to a cube plus b cube plus 3a square b plus 3ab square. Like that you have to do. This also gives a complex number. Here we are not taking considering any conjugates. That means for n is equal to n, z to the power of n is equal to a complex number. That is equal to, let us say, x plus capital X plus capital Y. Because small x and small y we have already used. This is in this form. Then, what is the value of z to the power of n conjugate? That will be x minus capital X minus I into capital Y. Now, what is the modulus of Z small x minus small y, x minus iy? Then, this conjugate of Z to the power of n, what it is? X minus iy into x minus iy into x minus iy up to n values. For n is equal to 1, conjugate n to the power of n is equal to conjugate n to the power of 1 is equal to conjugate, that is equal to x minus iy. And for n is equal to 2, conjugate to the power of 2 is equal to n is equal to conjugate to the power of 2 is equal to x minus iy whole square, that is equal to x square minus y square minus I into 2xy. That means z square is equal to x square minus y square plus 2 into I into 2xy, z bar square, that is conjugate square, is equal to x square minus y square minus I into 2xy. This is nothing but x plus I into y. This is nothing but x minus I into y. X and y arbitrary, bigger x. X square minus y square we call it as capital X. 2xy we call it as capital Y. And we have already seen z to the power of n. We have already seen z to the power of n is in the form of a complex number, and hence z bar to the power of n is equal to x minus iy. Z bar to the power of n is x minus iy. Please try to understand how it has come. Please think over. Mathematics is thinking and doing. Where here capital X. Okay. Z to the power of n, z square is x plus iy. Z bar to the power of n is equal to x minus iy. In this form I have written. These both are complex numbers for non-trivial conditions. Now, what we have to find out? Z to the power of n whole bar. What is z to the power of n? Is equal to x plus iy. This implies z to the power of n conjugate is equal to x minus iy. But x minus iy we have already proved. It is nothing but conjugate of z to the power of n. You please understand the difference between these two. We have taken the conjugate, we powered it to the power of n. Here, complex number is powered to the power of n and then conjugate is taken. Both are same. From this, we say that z to the power of n conjugate is equal to conjugate of z to the power of n. This is our answer. Please, it's a very, very important derivation, regularly used in engineering and sciences. Whether you opt for the sciences or engineering in future, it will be a very useful derivation. And it will be this type of derivations, this type of questions being asked in IIT JEE, because these are all useful derivations, and Maths Olympiad. Ultimately, what is our conclusion is that a complex number when powered to n and the conjugate of that powered complex number is equal to conjugate of the original complex number to the power of n. This is a very important derivation, and we can easily, from the given complex number, we can easily find out z bar. Z is equal to here x plus iy. Z bar is equal to x minus iy. That means x plus iy to the power of n complex is equal to x minus iy to the power of n. Please remember this. It's a very important derivation. Very important derivation, because z bar is x minus iy to the power of n. This is x plus iy to the power of n complex, conjugate. This is what is the derivation. With this, I want to conclude today's lecture, and I am from Maths and Science by IITian. If this video added some value to your knowledge, value addition took place, then please kindly share, view, review and comment on my other videos also from the channel Maths and Science by IITian. And please subscribe to my channel. Thank you for listening to me. Thank you for viewing my lecture. Best of luck to everybody.